Hey everyone, we're back for the 9.2 journal, and the last one was a little bit tiring with all those radicals. I really hope that you remembered us doing those from earlier in the year, so maybe that helped out a lot too. This time we're going to go back to quadratic equations, and we're going to start with graphing them actually. So here we go with graphing quadratic equations. So the first part says to sketch y equals x squared minus 2x. And I'm going to take that approach that we were doing where we find the vertex first. So in that version, we're going to go ahead and make sure that we have all the x pieces on one side of the equation, and yeah, they're on the right side. And then we're going to figure out what are the values of a, b, and c. Looking at this, there is no number in front of x squared, so a equals 1. Remember, if there's no number in front of a variable, there's always a 1. B is the number in front of the linear term, and that is -2. And there is no c here, so if there is no c, we're going to say c is 0. Based on those three values, we know a couple of things. C gives us the y-intercept, so we know we get a big fat point at 0, 0. We also know that the line of symmetry is going to be at x equals -b over 2a. So what is b? b is -2. 2 times a is 2 times 1. So this is negative of -2 over 2. -2 over 2 is -1, so the opposite of -1 is 1. Zooming in here now, we can draw a vertical line at x equals 1. All right, so there's my line of symmetry. The next thing to do is to figure out, where is the vertex? And the vertex is the y-coordinate, the x-coordinate of the vertex is along that red line. To find the y-coordinate of the vertex, we're just going to substitute 1 into the equation, because remember, 1 is the x-coordinate of the vertex. So if y equals x squared minus 2x, when we substitute 1, we get 1 minus 2 times 1. Well, 1 squared is 1, 2 times 1 is 2, and 1 minus 2 is -1. So 1, -1. All right? From here, I notice that I'm going to need a corresponding point that goes along with this y-intercept. So that would go here, taking properties of mirror of the reflection along the line of symmetry. And then if you notice, this goes over 1 and up 1. The next one should go over 2 and up 4. So over 2, up 1, 2, 3, 4. That's that quadratic pattern. Over 2, up 4, or just with the symmetry. The next set of points would go over 3 and then up 9, but we don't have to worry about that. We've got enough points to make a parabola at this point. That looks pretty good to me. What is the definition of the x-intercept of the graph? And that's where the graph passes through the x-axis. There are two x-intercepts, and they happen here at 0, 0, and here at 2, 0. X equals 0 and x equals 2. What is the definition of the solution of a curve? And that is the same. That is where the curve crosses through the x-axis. So it has to cross the x-axis when you say that the solution is equal to 0. And then there are two solutions to this curve. That's x equals 0 and x equals 2. Whoa, wait a minute here. Is that a coincidence? We got the same answer for part B and part C. And no, it's not a coincidence. The x-intercepts of f of x are the solutions to f of x equals 0. That is a very, very powerful theorem, and we're going to be definitely using that in the future. So let's take letter B here, and we'll do the same thing. We'll try to figure out where the solutions to this curve are. First of all, find the line of symmetry. Ooh, this is a little bit ugly. We have x equals negative 1.5. No big deal. We'll just go ahead and draw that. You'll notice that I expanded my axis by making each line 0.5 rather than 1.5. That has the effect of spreading things out, and it allows me to draw x equals 1.5 with a little bit more fidelity. Next, let's go ahead and substitute 1.5 into our equation, or at least the left side of the equation, just so we can find the vertex. Decided to change my y coordinates so I could fit that negative 2.25 a little bit cleaner. So there we got our negative 2.25. The next thing that I'm going to work on is c equals 0, and that is the coordinate of the y-intercept. So over here, 0, 0. And then we have to be symmetric, so we have to get that point that is 1, 2, 3 to the right. Actually, that's 1.5 to the right of our axis of symmetry. Let's find a point 1.5 to the left. 0.5, 1.5 to the left is right here. And then we'll use those 3 points to draw our parabola. Okay, not bad. I think you're pretty confident with drawing your parabolas here now, so we'll move on. Even more parabolas. Maybe we should do another one. Let's do letter, I don't know, F? Why not? A, B, and C. Axis of symmetry. Ooh, look at that. We got positive 1.5 this time around. And I think the only thing I'm going to do next is to figure out maybe 1 point to the left and 1 point to the right, which is conveniently easy to do because I have c equals negative 6, which is the y-intercept. So let's figure out the y-intercept. As you know, I strongly believe in symmetry. That's why you can have a point to the left and a point to the right of the parabola. And the one thing that I forgot is to put the vertex on this. Why didn't you remind me to put in a vertex, huh? Let's figure out the vertex. Turned out that my vertex had a y-coordinate of negative 3.75. Now that I have 3 points, that's all I really need to do to draw my parabola. Here we go. Is our parabola. There we go. Okay, so now I think we've done everything we need to do here in this first part. Let's move on. Okay, communicate your answer. I think we'll do the same thing before. How can you use a graph to solve a quadratic equation in one variable? You're going to make the equation equal 0. It may not always equal 0, but you make it equal to 0. And then the solutions are or is the x-intercepts. Okay. After you find a solution graphically, how can you check your result algebraically? Well, substitute. After you substitute, make sure that the equation is true. How can you determine graphically if a quadratic equation has no solution? And this is a little bit of a logical extension of question 3 in communicate your answer. But if the solution, if the curve does not have an x-intercept, then it has no solution. Because remember, the x-intercept is the same thing as the solution. So we have to have x-intercepts in order for a curve to have a solution. Vocabulary term, this is a little bit of a review, but a quadratic equation is any equation where the highest power is 2, hence quadratic. Okay. Over at core concepts, you may want to take a note of that. This is how we solve a quadratic by graphing. First of all, we write the equation equal to 0, like I mentioned earlier. Secondly, we graph the related function y equals ax squared plus bx plus c. Third step, we find any x-intercepts. The solutions or roots, we were calling it that last chapter, are the x-intercepts of the graph. Okay. Graph it, find the x-intercepts, good to go. Now, this might be the first time we're seeing this, but there are 3 situations that could arise here. Number 1, and probably the most ideal situation, is if the parabola goes through the x-axis 2 times. If that's the case, there are 2 solutions. If the curve only goes through the x-axis, and by goes through the x-axis here, I mean it doesn't even actually go through the x-axis. It just touches the x-axis at the vertex. Then there's only going to be one solution. And if the curve is way too high or way too low, so it has no x-intercepts, then there are no solutions. Okay, so let's solve a couple of these by graphing. I'm looking at number 3, and that one looks pretty nice. So let's try 3. First of all, I'm going to figure out the values of a, b, and c. Next, I'm going to find the axis of symmetry. Next, I'm going to substitute the x-coordinate of the axis of symmetry in order to find the vertex. Here we got our -1 substituted into the equation. Execute all the multiplication. Do all the addition, and that leaves me with 3. So my vertex is over here at 3. The next thing to do is probably to find the y-intercept, and that's equal at y equals 4. We're going to use the y-intercept here to figure out a third point on the parabola. Since it is over 1 and up 1 from the vertex, I'm going to go over 1 and up 1 on the other side of the axis of symmetry. That gives me 3 points, and I'm ready to graph a parabola here. All right, not a big deal. I hope it's not a big deal. Let's take a look at question 6. I notice, looking at it, that this equation isn't equal to 0. Remember I said that would come up again? So we're going to make this equal to 0 over here on this side. So I'm going to rewrite it. X squared equals 2x minus 6. And then I'm going to subtract 2x from both sides. Subtract 2x from both sides and then simplify. Now we're going to add 6 to both sides. There we go, add 6. And finally, that is my equation that's equal to 0. Good. And we're going to call that y. The y coordinate is going to be the same. A, B, and C. Here we go, A, B, and C. Next thing is to find your axis of symmetry. There we go. That's a nice axis of symmetry. Our next step here is going to be to figure out the vertex. So let's substitute 1 into the equation. And just a quick reminder, since I've solved for y equals x squared minus 2x plus 6, I'm really never going to go back to this first equation. That's a form that was difficult to solve, so I'm going to substitute 1 into my new equation, which I have highlighted. Next, of course, let's do all the multiplication. Add them up, graph them up. Okay, I got a vertex of 1, 5. Maybe I should write that over here, 1, 5. And next, I'm going to write down, well, let's figure out where the y-intercept is, and that's going to be at the value of c. So here's my y-intercept. Y-intercept is 6. So I'm going to put a point at 6 and the y-axis. Use symmetry to carry that through on the other side of the axis of symmetry, and draw my graph. And now I think the question that I forgot to answer in the first one, we'll go back to it, is where does this curve cross the x-axis? And it doesn't. So it doesn't cross the x-axis. You notice that it's floating way above the x-axis. So no solution. Let's go back to number 3 and see if we can figure out the solutions. I don't know if I'm lucky or if I'm just picking these in some kind of a pattern here, but this really doesn't look like it has a solution either. No solution. Which means we really should probably find a parabola that does have a solution. Let's see. Okay, let's try number 8, huh? How about 8? A, B, and C? Wait, no, first of all, is it in standard form? It looks like it is. We see a 0 on the right side of the equal sign. So the next thing is A, B, and C. That C is 25. That's going to be way up the axis, isn't it? Now that I have my A, B, and C, same thing. What's the equation of the vertex? No, the axis of symmetry. So it turns out the axis of symmetry is at x equals 5. Next thing to do is to figure out that vertex. So we're going to substitute 5 into the equation. This is a good place to remind you that the 5 comes from the axis of symmetry. So now let's do some multiplication. And let's add that all together, and I'm getting a very fortunate 0. Isn't that amazing? 0. Okay, here is my vertex at 5, 0. Next, I know you know what's coming next. It's the y-intercept. The y-intercept is 25. I notice that I don't have 25 lines on my graph vertically, so I'm going to space everything out by 5s. Okay, counting by 5s, that means 0, 25 is up over here. And let's find a point symmetric to that across the line of symmetry. That is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here is that point across that line of symmetry. And I'm just going to draw my parabola next. And here's that situation that I was alluding to before. This curve only touches the x-axis one time. It doesn't go through the x-axis. It just intercepts it right at the vertex. So we only have one solution. Maybe I should write that with the word one, huh? One solution. And that is going to be x equals 5. Okay? There we go. Let's see. These next few, it says to find the zeros. So all we need to do is figure out what are the x coordinates here. That's x equals 0. And then that is x equals 1. And then this must be x equals 3. Not a big deal here. Oh, I noticed they're factored up here. So we can just, kind of play along with the factors. This one isn't fully factored, interestingly enough. So let's factor this. That was an easy quadratic, so I didn't have to use the extended method because a was equal to 1. So I get x plus 1, x minus 1, x minus 3. Those are my 3 solutions. So the solutions are x equals -1, x equals 1, and x equals 3. So I think you know how to do these. These are pretty fun, actually. I think they're fun. And lastly, we're supposed to estimate these to the nearest tenth. Okay, let's do this first one. Let's see, somewhere between 0 and 1. It doesn't quite look like 0.5, so I'm going to say x equals 0.4. This is between 2 and 3, right here, and it's a little more than halfway, so I'm going to say x equals 2.6. Sure, we're just estimating anyways. Number 17. This is somewhere between -1 and -2, and it's closer to -1. So I'm going to say, let's say x equals -1.3. And this one over here, this is between, let's see, 1, 2. This is between 2 and 3. So this is, let's call that -2 or positive 2.3 also. And 18. Let's see, -1, -2, -3. So this is close between -2 and -3, closest to -2. So I'm going to say maybe -2.2, -4, -5, and -6. So this is between -5 and -6, closer to -6. So maybe -5.7. Okay. And that's it, everyone. All right. So that's our section 9.2. So have yourselves a good day and get to your homework. See you later.